Today I will talk about the Helicity and the Chirality. In the previous videos, we discussed the Spinor build as a spin one half particle. So the Spinor builds governed by the Dirac equations. The Dirac equations are given by the additional Gamma matrix in here. Mu partial mu I minus m psi equal to 0. And such Dirac equations are actually the triangle equation form if we multiply the additional factor. And this mass that becomes a mass page, so the Dirac equation solutions are given by the primary form. And in the previous video, we discussed that there are several degree freedoms for the spinor to build, like the spin and the matters and antimatters. And today we'll talk about the helicity and chirality. The helicity is the relation between the momentum and the spin. This is the classicalism. So we can consider the alignment between the spin and the momentums with the inner products and the normalizations with the magnitudes of momentum. This is deep definitions of the helicity. And by using the spin operators with the Pauli matrix, this can be written by this 4x4 matrix form. For the right-handed helicity with h equal to 1, the spin directions and the momentum directions align. For the left-handed, the spin direction is the opposite with the momentum directions. Such a helicity is a quantity is not Lorentz invariant, because if we change the some of the frame or observer, then the moving direction, the momentum direction can be changed in the other frame. So the helicity is not a Lorentz invariant quantity. So this is a good intuitions as a classical regime, but this is not useful to classify this right-handed and left-handed helicity states because it is not rational. And when the momentum direction is not aligned with the jet directions, but the spin direction is aligned to the jet directions, then we can bind the helicity eigenstyles for such a no alignment between the ones and the spin direction. So let's set the momentum directions are given by the spherical coordinate with the theta and the pi. Then by using the spin operators with the 4x4 matrix element, we want to solve this eigenvalue problem. And then in the momentum P, we can insert these momentum directions. Then these eigenvalue problems reduces in such a form. And if we solve this eigenvalue problem, then we can obtain the Helicity eigenstate for the right-handed one, and the left-handed one as a functions of the theta and the pi, and also for the energy, momentum, and the mass. Then this is eigenstate, and eigenvalues again by the plus minus 1. And also for such Helicity eigenstate, if we transform through the parity transformations with the gamma 0 matrix, then such a parity conjugations changes between the right-handed and the left-handed helicity state. But such helicity state is another Lorentz invariant quantity, so we can find the Lorentz invariant representations of the helicity state. This is not classicalism. This is intrinsically properties of Lorentz invariance. And there's a gamma pi matrix, which is defined as a multiplication of the gamma matrix, gamma 0s, gamma 1, gamma 2, gamma 3. And such a gamma pi matrix gives a chirality. By using this gamma pi matrix, we can make the projections of operators. PL for the left-handed chirality, the PR as a right-handed chirality with the 1 minus plus gamma pi equal to 2. This gives the left-handed chiral states and the right-handed chiral state. This is projection operator, so this behaves like the projections. And but adjoint spinor, if the PRs acts on the spinors, adjoint spinor, then this becomes a UL bar. And if the PRs acts on the V, adjoint of V, this is the arm spinor, then this becomes a VL bar. So for the anti-matter spinors, the projection operators acts like the opposite chirality. So if PRs act from the anti-spinors, then this gives the lap anti ones. And also they satisfy the projections applied to the large and PR square equal to the PR, it is lap, and the PR times PR is equal to 0. And by using the commutative relation between the gamma zeros and the gamma fives, PR gamma mu becomes a gamma mu PR. So that if we swap the projection operators on the gamma matrix, the lap and the light and the ones that changes. So by using the such as identity, we can set two paths. First of all, the UR bar, UR keeps the 0 because the UR bar is the U PR because this is a joint spinor, and the UR is the PR U. So there's the PR, so this gives a 0 always. So for the mass term, for example, in the Lagrangian, we can like the psi psi, and we can decompose this mass term with the left hand this one and the right hand psi r and psi r, both adjoint, and also the psi r, the original spinor. Then the cross term, psi alpha, psi r are alive, and the psi alpha and the psi r are alive, but the psi alpha, psi r does not alive, and psi alpha, psi r does not alive. So but the mass terms that there are always a cross term between the psi and the psi r. And if we insert the gamma matrix between the adjoint spinors and original spinors, then the UR bar gamma mu is always a 0, because UR bar is U bar PL, because this is the adjoint spinors and gamma mu, and the PL U. So if we swap the gamma matrix and the projection operator, then this gives the PL. And again, the PR equal to 0, so always this is like equal to 0. So for the interaction terms of the Dirac Lagrangian, this is mass Lagrangian. So interaction terms for the kinetic term, I gamma mu psi, I gamma mu is the partial mu psi. The shift always the psi L gamma mu partial mu psi L is allowed. So this is some colors type, and so we can compare between the colors and the helicity. For the relativistic case, the chirality and the helicity is the same, but in the non-relativistic case, the helicity and the chirality is the difference. So in the relativistic and the mass loss limit, the velocity is almost nearby the speed of the light. So the directions cannot reversed by the prime changes from some transformation. So the helicity and the chirality is the same in such a relative limit. To be specific, it's with quantitatively, the right hand is helicity side. Contains the right hand is the chirality and the left hand is chirality. So this is helicity side. But for the non-relativistic case, there might be the right-hand chirality and the left-hand chirality combines, and both the right-hand ones can be expressed by this coefficient and left-hand chiralities can be expressed this factors, and this case actually given by the E about the E plus M. And when the relativistic limit is almost 0, so the K becomes 1. So the left-hand chirality is becomes almost 0. So the right-hand helicity and the right-hand chirality becomes the same. Such as distinct estimate between the helicity and the chirality is important because we will use such a chirality size in the wig interaction because wig interactions are different for the left-hand this one and the right-hand this one, which is called the parity relations and the CP relations.